Okay. Now see here some important points I am written here. Heading is AC analysis of the differential amplifier. The first point is, this is our differential amplifier. Yes or no? It consisting of two transistors, and here we are applying two input voltages and we are calculating voltages output at V0. Okay, V0 is proportional to difference of two input voltages, that is V in 1 minus V into R, Vs1 minus Vs2. Right? Now see the first point. To find the voltage gain that is represented as a AD for differential amplifier, please remember, voltage gain of the differential amplifier, voltage gain of the operational amplifier is a difference. Differential amplifier is a difference. Differential amplifier is a first stage of the operational amplifier. Remember, to find the voltage gain of the differential amplifier, that is AD, as well as and input resistance of the differential amplifier. To find these two values, here we have to go through performance of the AC analysis, right? For doing AC analysis, please remember the important point I am written here. Please, all of you following?
Yes, sir.
Yeah. For doing the AC analysis, we replace the transistors with T model. Transistors with the T model, as well as whatever the DC sources, set them to ground, and if you find any capacitors, should be open circuited. Okay, and AC voltage sources should be normal. So to perform the AC analysis, wherever you find DC voltage sources, that should be grounded, and if you have any capacitors in the circuit, that should be open circuited. AC voltage sources should be same. Okay. Coming to in DC analysis, wherever the AC voltage sources, we are making to ground. Yes or no?
Yes, sir.
Okay. For DC analysis, for AC analysis, we have to make the whatever the DC voltage sources to ground. As everyone is clear up to this point, this transistor is replaced by a T model. See here, this model is look like as a T model, right? Like T. Okay.
Yes, sir.
Now see here, the base is replaced by a current IB, and collector is replaced by IC current, and emitter is replaced by a dynamic resistance, that is RE. So this is our differential amplifier. In differential amplifier, each transistor will be replaced by a T model like this one, right? The next step, I am going to replace the wherever the transistors in the figure. See it. This is what is the first arrangement here we have to do. First arrangement is, I said already,
Transistors. Second arrangement T.
First arrangement is wherever the DC voltage sources. Yes or no? Here see this diagram. Where are the DC voltage sources? Tell me. దీంట్లో DC voltage sources. Huh?
No DC voltage.
AC voltage చెప్పండి ఎక్కడ ఉందో?
VS1, VS2.
This is DC voltage sources are plus VCC minus VW. అవునా కదా? Plus VCC అంటే voltage అనా?
Yes, sir.
Here it consisting of two DC voltage sources. Is there any capacitors are there?
No, sir. No capacitors.
No capacitors, right? So here in this figure, having two DC voltage sources, I want to make that DC voltage sources to ground. See here, first one, DC voltage sources is grounded. Yes or no? This one is grounded and this one is grounded. I am putting same as AC voltage source.
Yes,
This is
sir.
V1, Vn2. Right? And this is our first circuit, that is a differential circuit, just I am replaced. Second case, I said each transistor Q1 as well as Q2 is I am arranged as a T model circuit. See here, this is my IB1, this is my IC1. Yes or no? Here, this is my IC2 and it is my IB2, right? And here resistance RE, dynamic resistance. This is Q1 transistor. I am replaced here. This is a Q2 transistor. If you observe here, this is my T model. Yes or no? The Q1 as well as Q2 transistors. Yes. I am replaced with T model. Yes or no?
Yes, sir.
All of you following?
Yes,
Yes, sir.
Okay. Right. Now, see here. The same model, I am redrawing the figure. See, first, I am starting here. This is the resistance RE, first RE, right? What is the current flowing through this resistance? Cheppandi, what is the current flowing through this resistance?
IC1.
Huh?
IC1.
IC1 ekkadundira babu. What is the current name here?
IE1.
What is the current name here?
IE2.
Both the currents are entering through this resistor. Yes or no? The current flowing through RE is IE1 plus IE2. Is it right?
Yes, sir.
See here, this is my RE. The current flowing through this one is IE1 plus IE2. Right? Up to this point, I am completed. Next, I am going towards like this side. So, from right side, what is the resistance is here?
RE, sir.
RE. What this resistance is RE. What is the current flowing through this resistance RE?
IE1.
IE1.
Here, this is my resistance RE. Current flowing through that resistance is IE1. Right? Then, up to this point is completed. Right? Next, from this point to this point, tell me after RE, what is the current is here and what is the resistance and what are the voltage sources?
IB1, RS1.
Yes.
IB1 and RS1. RS1, VS1.
Resistance. Applied voltage source is Vn1 and current flowing through this one is IB1. Is it right?
Yes, sir.
Yes, sir.
Yes. We have started our journey from here. And this is our first node, this is our second node, and this is our third node. And after, at this point, another, here I am moving towards like this one. Okay, tell me, what is here?
IC1 current flowing, sir.
Current flowing is IC1. What is the resistance is here?
RC.
RC.
Resistance is RC. Yes or no? Current flowing is IC1 and resistance is RC. Right? Everyone got the point what I am saying?
Yes, sir.
Similarly, another
Yes,
side
sir.
of the transistor, this transistor, see here, I am moving from here to here. What is the resistance is here?
RE.
RE, what about the current?
IE1. IE2.
So, see the current is IE2, resistance is RE, right? After that, here, this direction, tell me.
IB2 current flowing.
IB2,
Yes,
RS2 resistor.
current is IB2.
Voltage is
resistance
V.
Resistance
RS2.
RS2.
Yes, applied voltage is V into. Right? After that, this one. Right? What is the current is here?
IC2.
IC2.
IC2 as well as what is the
RC
resistance?
resistor.
RC resistor.
RC.
right? So this entire figure, I am replaced with another type of arrangement so that is easy to analyze the operation. I hope everyone is clear. అర్థమైందా నా ఈ ఫిగర్ ఎలా వచ్చింది?
Yes, sir.
Is there any doubt?
No, sir.
Okay, thank you. Now see here. What is V naught here? What is V naught? From this figure, what is V naught?
1 minus V2.
V1 minus V2. Yes or no? V naught is equal to V1 minus V2. Is it right?
Yes, sir.
And for each transistor, we know that IC is always equal to beta into IB.
IB.
Yes, beta is the gain. We are already calculated yesterday. Beta is the gain. Right? Then IB is equal to what? IB is equal to IC by
Beta.
Beta. Please remember here we are calculated AC analysis. So that I want to write here beta AC. Beta AC. Right? And because of the value of beta is very much higher, IB is a very small value. Beta value is very much higher means the gain of the operational amplifier, the gain of the differential amplifier is a very much higher. So because of that one, beta is very high value, so that IB value is a very smaller. Right? Actually, the current IE for single transistor is IB plus IC. Yes or no? For because of IB value is very smaller, IE approximately IC. So wherever the IC, I want to IC approximately equal to IE. So that beta AC is equal to IE by IC. Sorry, IE by IB. Yes, everyone is clear?
Yes, sir.
Yes, sir.
ఇది గుర్తుపెట్టుకోండి. And another important is here. Tell me what is the V1? What is the V1 at this point? What is the V1? Tell me what is the V1?
RC.
ఇక్కడ చూసుకోండి, ఇక్కడ V1 ఏంటి నాన్న? V1 is equal to ఏంటి? V1 is equal to RC ఎందుకు అవుతుందిరా? V is equal to ఏంటి? V is equal to IR ఉండాలా, అవునా కదా? Voltage is equal to
IC1 RC.
Yes.
IC1 RC.
Yes, IC1
RC.
RC. Similarly, V2 is equal to here
IC2 RC2.
IC2 RC. Right? Now here I written V0 is equal to what? V1 minus
V2.
Yes, V0 is equal to what is V1 here?
IC1 RC.
Yes, IC1 RC. So I want to take the common of RC. That is IC1 minus
IC2.
remember
IC2.
point. Is it right?
Yes, sir.
Yes, sir.
అర్థమైందా? Now I hope everyone is clear about this figure. Is there any doubts? Ask now itself. తర్వాత అర్థం కాదు. Okay, thank you. Now see here. Here I am going to write a KVL equation at loop 1. I want to write KVL equation at loop 1. Yes, this color is visible.
Yes, sir.
Loop 1. Or tell me the equation here. Anyone, please tell me the KVL equation for this one. See it. What is the voltage here? Is here first one.
V in.
Minus V in 1. Yes or no? Then
Yes, sir.
plus
R.
IB1 into RS1.
Yes.
Plus IB1 into RS1. Then plus
RE1.
yes,
Plus
good.
I1
IE1. Plus
RE.
RE into I1 plus I2.
I2
very good. Yes, RE into IE1 plus IE2 is equal to 0. Yes or no? It is a KVL equation.
Yes,
Yes,
sir.
sir.
Right. So I want to rewrite this equation. V in is equal to V in 1 is equal to IB1 RS1 plus RE IE1 plus RE. I want to separate this one. IE1 plus RE IE2. Is it right?
Yes, sir.
Yes, sir.
Now tell me what is IB equation. Yes, IB I am written already. IC by beta. Yes or no?
Yes, sir.
IC is same as IE. Right? So here I want to write IB1 is equal to IE1 by beta.
Beta.
Right?
Yes, sir.
Now tell me what is the equation now. Tell me.
IE1 beta into RS1.
IE1 beta by beta into RS1 plus
Yes.
RA into IE1.
Very good. V in 1 is equal to IE1 beta RS1 plus RE IE1 plus RE capital RE IE1 plus RE IE2. Right? Here I want to make the common of IE1. IE1. Cheppandi.
RS1 by
RS1 by beta
Beta plus RE plus RE.
plus RE plus capital RE.
into I2.
RE plus RE IE2.
IE2.
Right. Now see here, the input resistance RS1 beta is very much smaller than RE plus RE. This one is very much smaller than compared to this one. Therefore, V in 1 is equal to IE1 RE plus capital RE and RE IE2. This is IE2. This is the equation 1. V in 1 equation 1. Let us assume this is equation 1. Yes, up to this point everyone is clear?
Yes, sir.
Yes,
Babu,
sir.
అర్థమవుతుందా నాన్న?
Yes, sir.
Right, I'm going to write another KVL. Yes, from this loop, like this is called it as a loop 2. Right, writing KVL at loop 2. Now here I want to yes, please wait. I want to write the signs. This is plus minus, here plus minus. Okay, here is plus minus. Now tell me.
Minus V into
Minus V into
Minus V into
plus
plus
IB to
IB2
RS2
IB2 RS2 plus
plus IE2 RE
IE to RE
yes
plus RE into IE1 plus IE2.
RE into I1 plus
I1
is equal to 0. Yes or no?
IE2.
Yes, sir.
yes, sir.
Yes, just a minute. This is equal to 0. Is it right?
Yes, sir.
Yeah. Now tell me, once again, I want to write the same equation. V into is equal to,
IE,
so what is IB2? What is IB2?
IE2,
Here also I want to replace IB2.
IE2.
Yes, what is IB2? Tell me.
IE beta.
IE2 by beta.
IE2 beta.
IE2 by beta.
Very good. మీరు ఇలా కొంచెం రెస్పాండ్ అవుతే నాకు కూడా హ్యాపీగా ఉంటుంది నాన్న. Now here V into is equal to చెప్పండి IE2 by beta
Beta RS
RS2
RS2
2 plus
RE
plus RE
E2.
plus RE
Here I want to separate this one. IE1 plus
IE1 plus IE.
Right. Now here I want to take the common of first I want to write
IE2.
first I want to write IE1 terms, only one term. Yes or no? IE1 term.
Yes, sir.
RE into IE1 plus here I want to take the common of IE2.
E2
చెప్పండి.
RS2 by beta
RS2 by beta.
Yes.
plus RE
RE
RE plus capital RE.
Yes, is it right?
plus capital RE.
Yes, sir.
Okay.
Yes, sir.
Now the same arrangement, whatever we are done, the above one, beta is very much smaller than RE plus RE. Yes. Now tell me, what is the final one?
RE plus
RE
IE1
IE1 plus
V into is equal to RE
RE IE1 plus
plus IE2 into
capital
RE
RE
plus
capital RE.
RE plus
RE.
Capital RE.
Yes. This is second one. That is 2. I want to write both the equation at one place. Tell me, what is V in 1 as well as V in 2? V in 1 is equal to, చెప్పండమ్మా.
IE1 into RE plus RE
Yes, RE plus small RE plus
plus
IE2.
RE IE2.
E2 RE.
Is it right?
Yes, sir.
Yes, sir.
Yeah, V into
IE2
RE IE1
RE into
plus IE2 into RE plus RE.
is it right?
yes, sir.
Yes, sir.
Is all of you following? Following or not?
Yes, sir.
Yes, sir.
Yeah, I want to write this equation into matrix form. Please help me. How to write in matrix form? I want to write this equation into matrix form.
IE1 RE
First V in 1 and V in 2.
E2
Right? This is
Is
F
equals to
input side. Yes, is equal to
so is equal to IE1
S here RE
IE1
plus
IE2.
RE
Yes, RE.
here RE here again RE
V
RE plus
plus RE.
RE
RE.
into
IE1
IE1
IE1 IE2.
is it right?
yes, sir.
Yes, sir.
Yes, sir.
Yeah. I hope everyone is know about Kramer's rule.
Yes, sir. Krams.
You are already studied in intermediate. Yes or no? చెప్పండి.
Yes, sir. Yes,
తెలుసా
sir.
Kramer's rule? By the help of Kramer's rule, I want to calculate IE1 as well as IE2. Right? Now, we are going to calculate IE1 and IE2. What is Kramer's rule? Anyone? First, here I want to calculate IE1. IE1 చెప్పండి. So first term, because of I want to calculate IE1, these two terms will be replaced by V in 1, V in 2. Yes or no? This is a determinant. V in 1, V into the remaining is same RE here, RE plus RE by the determinant of this one. And here RE, RE, and here RE plus RE. Is it right? This is a Cramer's rule. Now tell me what is IE1 now? What is IE1? Chapandi?
V1 into RE plus RE.
IE1 is equal to Paina emosun Chapandi. Paina equation emosun Chapandi.
V1 into capital RE plus small re minus V
Yes,
into capital
V1
RE.
into RE plus RE minus V into
RE.
RE by
RE
plus RE whole square minus RE square.
into
Very
RE plus
good.
RE square.
Right. Is it right?
Yes, sir.
Similarly, tell me for IE2. IE2. IE2.
Determinant of
Yes. ఇక్కడ ఏమొస్తుంది ఫస్ట్
RE plus RE.
RE plus RE. RE.
Yes.
RE.
V2.
V in 1
V1 V
divided by
RE plus RE.
RE plus RE.
RE. RE.
RE plus RE.
Very good. Now tell me the equation.
IE2 is equals to RE.
V into RE plus RE.
V into
RE plus RE
RE plus RE. Yes. Minus
V1
V
into RE.
in 1 into RE.
RE by
RE plus RE
RE
whole
plus RE whole square minus RE whole square.
whole square.
Right. This is IE1, IE2. Right. Now see this equation here. At initially we are calculated one V0 is equal to RC into IC1 minus IC2. Right. The same equation here. Once again, I want to write what is the IC. IC is approximately equal to IE. Yes or no?
Yes, sir.
IE1 minus IE2, right? We are already calculated IE1 equation as well as IE2 equation.
IE2
So that
equation.
here we have to calculate V0. How much, Nana?
Yes, sir.
Yes.
V0 is equal to RC.
Here, tell me the equation. What is V0?
V0 is equal to RC
Not equals to
into
RC into
IE1 plus
IE1
IE2.
minus IE2.
V0 is equal to
RC.
RC into
RC into IE1 minus IE2.
IE2.
IE1 minus IE2.
IE1 minus IE2. Right?
IE2.
Now V0 is equal to RC. What is IE1, IE2?
V in 1.
V in 1
first Japandi.
into RE plus RE minus V in 1 RE.
V in 1.
Yes. Yes. I want to copy that one so that it is easy. This is the first one, and the second one is
Minus.
yeah, I will put. Is it right?
Yes, sir.
Dear student, only 1 minute we left. I need 15 minutes to complete this derivation. Can you please rejoin once again? Within 15 minutes, I will end up.
Okay, sir.
Okay, sir.
Because is sagamlo undi kada derivation mali naaku ibbandi avutundi meeku ardham kaadu naaku ardham kaadu, right?
Okay, sir.
Please rejoin. V0 is equal to RC into What is denominator? Denominator is common. Yes or no?
Yes, sir.
Yes, sir.
Expand the denominator. Expand the denominator. A plus B whole square. Right?
Yes, sir.
RE square plus RE square
RE
plus
2
RE minus RE square.
RE.
Yes, now in this one, this RE will be cancelled. Now coming to numerator, see here in above numerator, I want to write wherever RE plus RE is common, here I want to take the common of RE plus RE. RE plus RE. Both the cases. Tell me, here V in 1 is there. Yes or no?
Yes, sir.
V in 1
V in
and
1
here
minus
V in 2.
V into RE.
Minus V in 2. And yes, and once again minus of. Again, here I want to take the common of RE. That is V in 1 minus of
R.
V in 2.
In,
Is it right?
yes, sir.
So again, is it minus or plus here? Because of minus into minus plus, right? Here we are getting minus. Is it right?
Yes, sir. RE plus RE, V in minus V in.
Now what about the V naught?
V
V naught is equal to RC into
C into RE plus RE, V in 1 minus V into.
Here I want to take the common of V in minus V in 1 minus V in 2. చెప్పండి ఇక్కడ ఏమవుతుంది V in 1 minus V into కామన్ తీస్తే ఏమవుతుంది
Minus RE.
RE plus RE
RE minus RE.
Minus RE. By RE square plus 2RE.
RE square plus 2RE. Is it right?
Yes, sir.
RE.
Okay. Now V naught is equal to RC. Here I want to write V naught by this entire one. V naught by V in 1 minus V in 2.
Into RE plus
Okay.
RE.
Is equal to RC into. చెప్పండి. This one will be cancelled.
And RE
by
RE by, here I want to take the small RE as a common. RE into RE plus
2RE.
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 Sir, no?
Yes, sir.
Correct enough?
Yes, sir.
Now it becomes I think we make a mistake, I think, somewhere.
Sir, plus RE వస్తుంది సార్ పైన.
ఇక్కడ ఏమొస్తుంది చూడండి అన్న, ఇక్కడ దీనికి మైనస్ వస్తుంది, ఒక ఏదానికి VN2 కి మైనస్ వస్తుంది, బట్ వాట్ అబౌట్ హియర్ మైనస్ ఇంటూ మైనస్ ప్లస్. ఎస్ ఆర్ నో? దిస్ ఇస్ ప్లస్. ప్లీజ్ ఇప్పుడు చూసుకోండి ఒకసారి. RE, this minus into minus plus V in 1 into RE minus V into RE. Is it right? అందరు నిద్రపోయారా? ఉన్నారా? పడుకున్నారా?
లేదు సార్.
రెస్పాండ్ కానున్నానా? పడుకున్నారంటే అమ్మాయి ఎస్ అంటుంది, ఏం చేయాలి? Now here RE plus
2RE.
2RE.
right. Now we know that V in 1 minus V in 2. We can call it as VD, difference.
Yes, sir.
Yes.
Difference.
Yes, sir.
Right? V in 1 minus V in 2. Difference of input voltages. Yes or no?
Yes, sir.
So here V naught by VD. V naught by VD is equal to
RC,
RC into
RE plus 2RE.
RE plus 2RE by RE into RE plus 2RE. ఏమైనా క్యాన్సిల్ అవుతాయి చూడండి.
RE plus 2RE.
RE plus 2RE.
E
Right.
plus 2RE.
Yes.
V
Okay,
naught by
V naught by VD. V naught by VD is equal to RC by RE.
into RE.
Any output voltage by input voltage, we can call it as what? Voltage gain, AV. This is the voltage gain of the differential amplifier, not operational amplifier.
Voltage gain of differential amplifier.
Yes, differential amplifier. Right. Has everyone got up to this point?
Yes, sir.
Yeah. Next one, we are going to calculate RE input resistance. That is RI1. Input resistance. Finding RI1. Now tell me what is RI1? Simply RI1 is equal to what is input voltage? V in 1 by what is input current? IB1. Yes or no? This is input one side transistor. RI1 is equal to simply resistor is equal to voltage by current. Correct. Because of RI1, I am applying voltage V in 1 by IB1.
Current IB1.
Yes or no? చూడండి నాన్న.
Yes, sir.
ఫిగర్ చూస్తే అర్థమవుతుంది నీకు. ఇక్కడ నేను ఇక్కడ దీనికి ఇన్పుట్ రెసిస్టెన్స్ కనుక్కోవాలనుకుంటున్నా. దీంట్లో అప్లై వోల్టేజ్ ఏంది? V in 1. ఓకే, కరెంట్ ఏంటి? IB1. ఓకేనా బాబు? ఆకలి అవుతుందా? Hello?
Yes, sir.
Remaining students, please respond. ఓన్లీ సాగర్ ఒక్కడే ఉన్నాడా క్లాస్ లో? ఇంకా ఉన్నారు ఎవరైనా?
అర్థమవుతుంది సార్.
Thank you. Now here V in 1, what is IB1? IB1 we replaced with IE1 by beta.
I by beta.
Yes or no? Now
Yes.
What? Tell me what is the IE1 equation, please. What is IE1 equation? We are already calculated. IE1 is equal to what?
V.
I want to copy that equation here.
V in 1. RE
Yes.
plus RE minus RE.
Yo, sorry. Yeah, this is V in 1 RE plus RE minus V in 2 by RE, right?
RE plus RE.
Now here I want to say one more important thing is here. RI1 is equal to V in 1 by IB1 when V in 2 is equal to 0. Remember this one. RI1 is equal to V in 1 by IB1 when V in 2 is equal to 0. This can be again written as RI1 is equal to V in 1 by IB1 we are replaced with IE1 by beta, where V in 2 is equal to 0. Now in this case, I want to put wherever the V in 2 as a 0. Now tell me what is the equation of IE1?
V in 1
V1
into
RE
RE
plus RE
plus
by
RE
RE plus RE.
minus
1
0
RE plus RE
minus RE.
by in the
RE
notes,
plus
RE plus RE square minus RE
yes,
whole
here
square.
I want to write RE common. This same వస్తుంది RE plus
RE square. RE 2R.
2RE. Yes or no?
Yes, sir.
Right. Now here we know the V in 1 value and IE1 value. So here I want to write V in 1 by IE1.
I1.
ఏమవుతుంది? This entire term is moving this side.
Yes.
RE plus 2RE
2RE
by
by
RE
plus
plus
R.
RE plus RE, right? Now in the equation to find RE1, sorry, RI1, that is V in 1 by IE1 by beta, where V into is equal to 0. Now tell me RI1. So for this equation I want to put by beta. Yes or no?
sir.
యా అప్పుడు ఏమవుతుంది? బీటా కిందికి వస్తే పైకి వెళ్ళిపోతుంది కదా ఆటోమేటిక్ గా.
Yes, sir. Beta
Yes,
by
beta
Beta
into
V.
this, yes, this entire term RE plus 2RE
2RE
by
RE plus RE.
this is the equation of RI1. Similarly, tell me about the RI2. Tell me about RI2.
Same.
Same. What is RI2?
V in 1 0 it is.
B in 2 by IB2, where
IB2.
B2.
B in 1 is equal to 0.
V in 1
This can be written as
0.
RI2 is equal to V into by IB2 is replaced by IE2 by
IE beta.
beta,
I beta.
where V in 1 is equal to 0.
0.
0.
Now tell me what is IE2?
RE
IE2.
V into V into RE plus RE minus V in
Into
1
RE
RE
plus
by
RE
RE
minus
plus RE whole square.
Right. ఈ డెరివేషన్స్ అన్ని ఈ ఒకటే యూనిట్ లో ఉంటుంది, ఏం టెన్షన్ పడకండి. This is IE2. So here I want to make V1 is equal to 0. Right here V in 1 I want to make V in 1 is equal to 0. Tell me IE2 is equal to now.
V into
V
RE plus RE by RE plus RE whole square.
Right. Here we are getting RE into RE
RE
plus
plus
E
RE.
plus
2RE.
2RE.
Yes. Is it right?
Yes, sir.
Now V into by IE2.
RE into
RE plus
2RE plus RE by RE
plus
plus RE.
Right. Now V
Beta.
into by IE2 by beta is equal to
Beta
into
RE plus
RE into 2RE plus RE by RE plus RE.
RE.
this is equal to RI2. Now tell me what is the use of AC analysis?